Hello, welcome to my video again. Now I am going to present Combined Maths A-Level 2025 Applied Paper Part B, question number 12B. In the question number 12B, as usual, this question has been given from the circular motion. Then this is the diagram given for this circular motion question. This says a smooth thin rigid wire AB in the shape of a circular arc radius A. This is the actually thin rigid wire. This rigid wire, this has been fixed. Somehow this has been fixed in this space in a vertical plane. Rigid wire AB. This is AB. This is point A. This is the wire AB. Radius A. Radius of wire is A. Angle AOB is 2 pi by 3. A small bead. A small bead of mass M is kept at A and projected around the wire with the speed of this. That means this bead is kept here and projected around the wire with this velocity. This initial velocity 7 GA over 2. So that the speed V of this particle when it has turned through an angle theta. When it has turned through angle theta, let's say this is theta. It is easy to mark this as an acute angle just for the demonstration, okay? When the particle has turned by angle theta, this is a position. Theta is between 0 and 2 pi upon 3. That means this equation is valid only between A and B. So that the speed of the particle V is given by this equation. We have to show this equation. V squared equal GA upon 2 3 plus O cosine theta. Okay, that is plus part. In order to do that, we can use our standard energy principle. That is standard mechanical energy principle. That says potential energy plus kinetic energy is equal to constant. In order to do that, we have to select zero potential energy level. Let's take this as the zero potential energy level, that the horizontal level passes through initial point A. This is a zero potential energy level. Then let's take another level, that is this particle's current position. This velocity, I mark it here again. Let's say this is current position, say S. This is initial position, zero potential energy position. This is the current position, S. Let's apply energy principle. From, let's say this level is again S naught. I rename this as S naught. Initial level, this is a final level. Initial level is this level, the level through A. The second level is the level passes when it has turned to angle theta. From the level S0 to S. Now let's read the sum of energy at initial level. Potential energy 0. Kinetic energy half m v square root 7 over 2 whole thing square equal to then total energy at state S. What is the potential energy? In order to write the potential energy, you can use this formula. Potential energy equal mgh. H is the height to the center of gravity. H is the height to the center of gravity from the reference level, zero potential level. Now what is the potential energy then? mg. H is this vertical height, a minus a cos theta. Okay, this is a. This vertical distance is from this triangle, a cosine theta. This is a minus a cos theta. That is a 1 minus cos theta. This potential energy in the level S. Plus kinetic energy simply half mv square. When you simplify this, you are getting v square equal 7ga upon 2 minus 2ga 1 minus cosine theta. Okay, how did you get this? Root 7ga upon 2 square. When you take this square, this root sign is eliminated. Then you can multiply both sides by 2. Then I moved everything to left side. In this way I got this one, okay? Now you can take GA out. You can take, if you take the term, if you remove GS as the common factor, GA you can keep out 7 by 2 minus 2 plus 2 cosine theta. Then what are you getting? 7 by 2 minus 2, that is 3 by 2. You can take this as a common denominator. Okay? That means once you simplify this, you are getting v squared equal g upon 2 3 plus 4 cosine theta. This answer we are looking for. If I repeat this, actually what we have done from the beginning, we apply the standard mechanical energy principle, that is for the isolated system. For the isolated system, sum of potential energy plus kinetic energy is constant. Here we have considered two stages, initial level and the level when the particle has turned to angle theta. This is the sum of energy in the initial level. The right side represents the sum of energy in the state S. This is potential energy. We apply mg. The height difference is a minus a cos theta. This is a kinetic energy, half mv squared. Then you can isolate V. In order to isolate V, you can write some convenient step, doesn't matter. Whatever the step you wrote, finally, you are getting this answer, okay? V squared equal Ga by 2 3 plus 4 cos theta. That's the answer for the first part of question number B, part B of the question number 12. In addition to this, it has been asked something, also show that after leaving the wire, the bead comes back to A. and find the speed of the wheel when it reaches A. Okay. Then how do you prove the second part? Actually, second part look like from the projectile motion. Even though you have not got the projectile as part B complete question, indirectly you got the some stuff in the projectile motion. Okay, that means that has been embedded into your circular motion question. Okay, whatever the story, we have to find that. In order to find this, let's consider the projectile motion. Okay, in order to explain that, I can draw this diagram again. Let's say this is the velocity. This is the velocity of the particle when it is leaving the wire. This angle is 120. For our convenience, whatever it is, I showed in degree. Maybe for my convenience, okay? We have to find this V1 first. What you have to show? After leaving the wire, we have to show after leaving the wire, the particle is coming back to original position. But my part does not come through the original position. Actually, this I did not do this by mistake. Purposely I do this. Because I am not supposed to draw this like this at the beginning. This is the vertical line through A. What is this point? Say this point is X. What is the point X? The trajectory. The trajectory of the particle cut the line OA at point X. Trajectory, that means the locus. Actually travel path, okay? Simply travel path. Travel path of the particle after leaving the wire. Cut the line OA at X. That's my assumption. But we have been asked to show particle is coming back through A. If the particle is going through A, what do you have to say? X is coinciding A. That means we have to prove OS is equal to OA. Let's do like this. Let's draw a horizontal line through this one. This point is B. Okay. Now let's do some simple geometry. This angle. Let's name this as Y, this point. If you can prove Yx is equal to Ya, if you are able to prove Ya is equal to Yx, if Yx is equal to Ya, that means the particle is passing through point A. What is Yx? That is the vertical distance between B and X. Otherwise, the vertical distance between first point and last point of the trajectory. What is By? Horizontal distance between first point and last point. Okay, now let's define some term. Let T1 is the flying time. This is a flying time to travel from B to X. From B to X. There is a flying time. Okay. To travel from B to X. In order to find the travel time, first we have to figure out this V1 and this angle. This is 120. This is 60, 30, Finally, this angle will become 60 degree. Okay, that means we know the angle of projection. Then we have to find the velocity of projection for the projectile motion. We can use this formula. When we substitute theta equal 120, you are getting value of V1. Let's use this formula. V squared equal this is not actually a formula, actually this is a result we obtained from the previous part. Using the result obtained from the previous part, we can deduce the velocity V1. Then we have to apply theta equal 120. Then V1 squared equal G upon 2, 3 plus 4 cos 120, G upon 2, 3 plus 4 times, from trigonometry you know this value, 120, cosine 120, cosine 180 minus 60 minus cos 60, minus half. Once you simplify this, you get G upon 2. That means V1 is equal to whole square root G upon 2. Okay. Now we got some enough information to find this projectile motion. Okay. As I have a lack of space, I have to erase this everything. Now this is the initial velocity of the projectile motion V1. Now let's find this time of flying. That means we have to use our standard equation SC equal ut plus half at squared. Some people simply say SC equal ut as there is no horizontal acceleration. What is S in this direction? This horizontal distance. A, this is 60. A sin 60 equal, what is U? U is the horizontal component of this V1, V1 cos 60 times T1. A is 0 because gravitational acceleration acting in the downward direction, there is no component in S direction. Okay, using this result, let's find the value of T1. What is T1? T1 equal, you can say, if you use trigonometry, A upon V1 sin 60 upon cos 60, that is tan 60. A upon what is V1 again, GA upon root 2. Tan 60 is root 3. Okay, what's the final answer? Let's simplify this quickly using a knowledge of radicals. I think finally you are getting this one. When you compile this everything, 6a upon g whole square root. Okay, think about this. This root is going up, 3 times 2, 6. Under the whole square root, you can compile like this. A upon root a will become root a. You remain with root g in the bottom. That is flying time, okay? Now I can erase this one. Now, what we need to figure out, because at the beginning I explained we have to find the vertical distance between B and X, that is Yx. Okay, now let's apply SC equal ut plus half at squared. Let's apply this equation of motion in downward direction. What is x? That means vertical distance between B and x. The vertical distance between B and x is simply yx. yx. Instead of x, I am writing yx. What is u? That is initial velocity in downward direction. You can resolve this velocity in the vertical direction. v1 sin 60 in downward direction minus v1 sin 60 plus half a is the acceleration, that is g, t squared. Here also you have to write t1 is squared. Okay, instead of u, I wrote this one, this component v1 in downward direction. This is u, half a, half g, t in t1. I put t1 in both places. Now what we need to do? You need to simplify this. You need to simplify this accurately as much as possible. Equal, what is v1? ga upon 2 square root. We proved that here. Sin 60, root 3 upon 2. T1, 6a upon g square root plus half g T1 squared, 6a upon g square root square, that means this original one. Okay, let's try to simplify this. What is this value? When you write this everything, okay, let's write everything under the single square root. Then it is easy to understand. GA36A, GA 3 times 6A, 16, 18A, GA times 18A, root G root 2, that is under the square root. Half is outside, that is for the first part. I simplified this first part. What is second part? G and G cancel, you are getting 3A. What do you get when you simplify this? G and G cancel inside. Then 18 over 2, 9. Square root 9a square means 3a. 3a divided by 2. That means negative 3a divided by 2 plus 3a. Okay, I started from writing this motion equation downward direction. We are looking for yx, that is vertical distance between B and x. Finally, we got this value for yx. This is not the end. When you simplify this, you are getting 3a by 2. That means the vertical distance between y and s. This is 3a by 2. What is ya? Let's find y. Ya is equal to, when you look at the diagram, what is ya? Yo plus oa. Y to a. The vertical distance y to a is equal to yo plus oa. Yo is equal to, from this triangle, this is also 60, A cos 60. A cos 60. Okay, from this triangle, this is A cos 60. Then this distance, O to A is A. A times half. A by 2 plus A. 3A by 2. Now we got our expected result. Ya is equal to 3A by 2. Yx is equal to 3A by 2. Therefore, Yx equal to Ya. That means S should coincide with this. That means after leaving the wire, particle passes through A. Therefore, particle passes through A, point A, after leaving wire. Okay, I think I provided the good explanation by describing or detailed explanation for this part. But that is also not the end. Finally, they have asked one more thing. Find the speed of the bead. Find the speed of the bead when it reaches A. How do you find this? When it reaches A, now it is reaching A, we know. We have to find this velocity or speed. Look like it is difficult. But if you think actually in the proper way, using the principle, that is only 1 to 2 minutes thing. You don't have to consider projectile motion. Otherwise, you have to find S component, Y component, using the flying time and find the resultant. You don't have to do. Actually, particles start from here. Particles start from here, move like this. The particle travel actually along this path. That means it came to the original position. That means in this level, initial velocity, initial speed must be equal to the final speed in order to maintain the total energy. Because potential energy is 0. In the initial position, potential energy is 0. When it comes back to original position, potential energy is 0. The kinetic energy should be equal, but masses are same. That means this V2 must be equal to root 7g upon 2. But as a speed, not as a velocity. How to explain this one? Then applying principle of energy. Applying principle of energy from start to end. Potential energy 0, kinetic energy half m v square, 7g upon 2 square. Okay, this is a very initial stage. At the final stage, again, potential energy 0, kinetic energy half m v2 square. By looking this, we understand V2 magnitude equal 7Ga by 2 root.